1,000 years. That's how long humans have been building machines to think for them. From a rack of wooden beads to a machine that operates at temperatures colder than outer space, this is the complete history of the computer. And we're doing it in under 10 minutes. 1822, Charles Babbage, a British mathematician, pitches the British government on something insane, a steam-powered calculating machine the size of a locomotive. He calls it the difference engine. It would have worked. But Babbage kept redesigning it, burned through government funding, and never finished it. Then he designed something even more ambitious, the analytical engine. Programmable. With memory. With conditional logic. In the 1830s. It was, in every meaningful sense, the first design for a general-purpose computer. And Ada Lovelace, mathematician, poet's daughter, genius, wrote the first algorithm intended to be run on it. The world's first computer programmer. In a corset. In 1843. Neither lived to see it built. But every machine that followed owes them a debt. 1890, the U.S. Census is a nightmare. 63 million people. Counting by hand will take 13 years. Herman Hollerith invents a punch card tabulation machine. Finishes the count in 18 months. His company eventually becomes IBM. 1936, Alan Turing publishes his landmark paper defining what computation means, the theoretical Turing machine. No physical machine yet. Just pure logic. But it changes everything. Then war breaks out. Nazi Germany uses the Enigma cipher machine. The Allies can't crack it, until Turing builds the bomb at Bletchley Park, an electromechanical computer that breaks Enigma daily. Historians estimate it shortened World War II by 2 to 4 years. 1943, Colossus, the world's first programmable electronic computer, is built in secret at Bletchley Park to crack German teleprinter codes. 1,500 vacuum tubes. The size of a room. Classified for 30 years. The computer is no longer theoretical. It is real. And it just helped win a world war. 1945, ENIAC. 27 tons. 18,000 vacuum tubes. Fills an entire building at the University of Pennsylvania. It can do 5,000 additions per second. Programmers are mostly women, Kay McNulty, Betty Jennings, Frances Belas, who rewire it by hand for each new task. It runs hot. The tubes burn out constantly. A cockroach once caused a malfunction, giving us the word bug. 1947, Bell Labs invents the transistor. Tiny. Cheap. Reliable. Doesn't need a warm-up period. Doesn't require a room full of engineers with spare tubes. The vacuum tube era is over before it really started. 1950s, IBM, Remington Rand, and others race to build commercial computers. Univac I predicts the 1952 U.S. presidential election correctly on live TV. America watches a machine predict the future. They're unsettled. They're fascinated. Computing has left the lab. It's entering the world. 1958, Jack Kilby at Texas Instruments and Robert Noyce at Fairchild Semiconductor, working separately, both invent the integrated circuit, multiple transistors etched onto a single chip of silicon. They both patent it. There's a legal battle. They share the credit. 1965, Gordon Moore observes that the number of transistors on a chip doubles roughly every 2 years. Moore's law. It holds, remarkably, for over 50 years. 1971, Intel releases the 4004, the first commercial microprocessor. All the logic of a computer on a single chip. 2,300 transistors. 740 kilohertz. Slower than your microwave timer. But the concept changes everything. 1975, the Altair 8800. A kit computer. No keyboard. No screen. You toggle switches on the front panel to program it. It sells out. Because nerds are nerds. A 19-year-old kid named Bill Gates writes software for it. His partner Paul Allen says, "This is it. This is the moment." They call their company Microsoft. 1976, Apple I, built in a garage by Steve Wozniak, arguably the greatest hardware engineer in Silicon Valley history. Steve Jobs figures out how to sell it. 1981, IBM PC. 1984, Macintosh. The graphical interface. The mouse. The desktop. Computing for everyone. 1991, Tim Berners-Lee switches on the World Wide Web. Not the Internet, that existed since the 1960s. The web, hyperlinks, browsers, pages. The layer that makes the Internet human. 1994, Amazon. 1998, Google. 2004, Facebook. The Internet stops being a tool and becomes an ecosystem. Then a habitat. Meanwhile, computers keep shrinking. Laptops. Palmtops. PDAs. Then, January 9, 2007. Steve Jobs walks on stage in San Francisco, holds up a black rectangle, and says, an iPod. A phone. And an internet communicator. He says it 3 times. The crowd loses its mind. The smartphone. A supercomputer more powerful than anything that existed before 1990, in every pocket on Earth. Within a decade, 4 billion people have one. The computer is no longer a machine you go to. It's a machine you carry. Then wear. Then, soon, implant. Today's computers are almost incomprehensibly powerful. The iPhone 15 has 19 billion transistors, more processing power than the entire combined computing capacity of Earth in 1995. But Moore's law is slowing. Transistors are now just a few atoms wide. Physics is pushing back. You can't go smaller than an atom. So the industry splits into 3 bets. 1. Specialized chips. GPUs from NVIDIA, originally built for video games, turn out to be perfect for AI. TPUs. NPUs. Chips built for one job, done insanely well. 2. The cloud. Instead of making your device more powerful, move the computing to massive data centers and stream the results. Your laptop becomes a terminal. The power is somewhere in a field in Virginia. 3. Something completely different. Classical computers think in bits, 0 or 1. On or off. Every calculation is a chain of binary decisions. Quantum computers think in qubits, particles that can be 0 and 1 simultaneously, thanks to a quantum property called superposition. And through entanglement, qubits can be linked across space, affecting each other instantly. The result, a quantum computer doesn't check every possible answer one by one. It explores all possibilities at the same time. For certain problems, cracking encryption, simulating molecules for drug discovery, optimizing global logistics, this isn't just faster. It's categorically different. IBM, Google, Microsoft, and a dozen startups are racing to build stable quantum machines. In 2019, Google claimed quantum supremacy, solving a problem in 200 seconds that would take a classical computer 10,000 years. IBM disputed the exact number. The race is very much on. The machines operate at 0.015 Kelvin, colder than the vacuum of outer space. They're fragile, experimental, and extraordinary. From wooden beads to quantum entanglement. From a teenager's gear-driven calculator to a machine that thinks in superpositions colder than outer space. Every single step in this story was built on the last. Every genius stood on another's shoulders. Every era seemed like the final answer, until the next one made it look primitive. So what does the next 10,000 years look like? We genuinely don't know. And that's the most exciting thing about it.